Here's why. We're going to be talking about lines that intersect circles today. Various ways that lines and circles can intersect. We're going to try and identify tangents, secants, and chords, use properties of tangents to solve problems. We're going to look at the interior of a circle, exterior of a circle, chord, secant, tangent, point of tangency, congruent circles, concentric circles, tangent circles, common tangents, everything! Yay! So much fun. Okay, here we go. A circle is just the set of all points in a plane that are equidistant from a given point, called the center of the circle. A circle with center C is called circle C, or it has the symbol for a circle and C next to it. Guys, you don't have to write down this next point, because if you don't get it, that's okay. Like, let's think about this. The interior of a circle is the set of all points inside the circle, and the exterior of a circle is the set of all points outside. There we go. Okay, outside, right? So if we don't know interior and exterior by now, just don't worry. Okay, all right. But here's where the good part starts. You need to write down all of this. Okay. You need to know what a chord, a secant, a tangent, and point of tangency is. I want you to write down the entire thing up here. Okay. Take your time, write it down. So we got several different parts of the circle that we're going to need to talk about. Here are a few of them. Okay, a chord. A chord is a segment whose endpoints lie on a circle. Okay, think a line segment. It's a line segment that endpoints are on the rim of the circle. I'm going to use the word rim to talk about the outer part of the circle. Why would I talk about it in terms of a rim? Because it looks like a basketball rim?
Yeah. I was thinking.
Nobody ever? Yes? No? Okay. So, that's why I talk about rim. The outer edge of the circle is called the rim. I'll call it the rim. Nobody else might. I don't care. All right? A secant. Here we go. A secant is a line that intersects the circle at 2 points. Okay? Notice that a chord and a secant are very similar. What's the difference between them?
One can go towards six.
No. Here we go. The difference between them. Guys, a secant keeps on going.
Yes, sir.
And a chord stops on the rim. That's simple. Okay? Got me? That's all it is. Alright, a tangent is a line in the same plane as a circle that intersects it in exactly 1 point. Okay, exactly 1 point, point C, and we call that 1 point the point of tangency. Okay? Alright, so just remember about tangency, okay? It nicks the rim at exactly 1 point. It never goes inside the circle, though. So 3 things we've just learned. A chord, a secant, and a tangent. A chord, a secant, and a tangent. Won't lie. 80% of this unit deals with those 3 things. Okay? We're gonna have a whole slew of properties that go with them. We're gonna start creating angles. We're gonna talk about arcs. We're gonna talk about we'll talk about that. Okay? But really and truthfully, about 80% of all the stuff we do revolves around chords, secants, and tangents. Okay? All right. Identify each line or segment that intersects circle L. I gave you the answers up here. You cut the lights off so that it's a little bit easier to see. Okay? Chords. JM and KM are both chords. Alright, so JM. Wait a minute, Mr. Hobbs. You told me that if it's got arrows on it and it goes forever, that means that it's a line and not a line segment. You're right, I did. How is this symbolized? As a line what? Segment. Correct?
Because there's points on it.
I know. It's really, really tough to understand this sometimes.
Oh, there's 2 of them. It's talking about there's one, there's actually one in the middle, and then it's talking about the other one. It's the same thing.
but it's like, there's another one that's above it, I feel.
Alright, so JM, when it references line segment JM, it's talking about just from point J to point M. That's all it's talking about. Okay? Right below it, it says secant, and it has line JM. And in that case, it's talking about points J to M and beyond. Right? So what's important here? The symbols, guys. Right? Your symbols. You got to remember the difference in the symbols between a line and a line segment. Yes, sir.
So you always have to write it, even if you're like, you always have to write like that?
Yeah. If it's a chord, then you write it as line segment. If it's a secant, then you write it as line.
No, I'm saying.
I want to make it that easy. Okay.
JM,
That's what I'm talking about.
How is a secant?
But, you know, that's what I'm talking about.
If JM's a secant,
I mean, it could be written as line M. Line M right here is a tangent line, right?
Yeah.
Okay? So I could have put, instead of J and M right there, I could have put line L. In that case, you wouldn't have a chord. Okay? You'd have to create points to get a chord, but you would have line L as a secant. No, right? This one is the one that you need to remember. Line segment is for chords, lines are for secants. Everybody with me? All right. Notice something about KM. KM. Is it a chord? Yes, it's a chord. It could be a ray. Very good. All right. That's okay. In this case, if it was a ray, it wouldn't be a chord because rays go forever.
But doesn't M go through?
Not if I stop at point M, like I do here and here. Okay? All right. KM is a chord. KM is also a diameter. So, here's something y'all need to understand. Every diameter is a chord. Think about it. Every diameter is a chord. Some chords are diameters. Every diameter is a chord. Every single one. Why? Because by definition, when you cut the circle in half, and you're going from the rim of the circle through the center to the other side, you have, by definition, a chord. Okay? It's a special chord because it goes through the center of the circle. That's what makes it a diameter. Right? Finally, we have radii. They're everywhere. Radii. LM, LK, LJ. What if I created one from L to H? Would that be a radii?
Yeah.
Yes, it would. Guys, there are an infinite number of radii. Anything that goes from point L to the edge or the rim of the circle, anything is a radius. Okay? Everybody hear me on that? Anything would be a radius there. And the principle that you have to understand about circles is this. All radii are created equal. All radii are created equal. It goes back to our definition. A circle is simply a set of points that are equidistant from point L. So, from the rim of the circle to L is the exact same, no matter where you are on this rim of the circle. And we call the line segment that goes from the rim of the circle to L a radius. It's always equidistant. So if I said that KL was 5 feet, how much would LM be?
5 feet.
5 feet. What about LJ? LH? L to anywhere on the rim? 5 feet. Once you find one radius, you find them all. Okay? Everybody with me on that?
Yeah.
Don't worry. You'll hear me say that about every day for the next 2 weeks. All radii are created equal. Any questions? Okay. You guys do this for me. Take 3 minutes Write for me a chord, a secant, a tangent, a diameter, and a radii. Y'all tell me true or false.
The timer was.
ST is a chord.
False.
That is true. Line segment ST.
You said. Oh.
Line segment ST is a chord. What about QR? Yeah, line segment QR is also a chord. Perfect. Secant. How about line ST? Good. Y'all see the difference in it? Line segment ST is a chord. Line ST is a secant. Tangent. I'm going to go with UV.
That's what I got.
Doesn't matter if I call it line segment, if I call it line, just UV. The point of tangency would be what? U. Maybe that's why I put V on there. Just to make sure y'all understood. U is the point of tangency. V is simply the tangent. Okay? It's not the point of tangency. It's just part of the tangent. Diameter. How about ST?
No. Yes.
Yeah, ST is the diameter. Radius, you could have chosen QP, or let's just do it let's go from the center of the circle out. You could have said
P.
PQ, PS, PT. If you wanted to, you could have created PR or PU. But that stinks. All right, we're done.
Wait.
What do you want? No, the diameter, it has to be line segment ST.
Okay, I was asking if it's gonna be S or line segment or.
No, I don't know what you're asking
Yeah, I
anymore.
don't know.
All right, guys. Go ahead. You know what? Just write the definitions down. Yeah, we might as well. Write these definitions down and draw the accompanying diagram. Okay? Two circles are congruent circles if and only if they have congruent radii. Concentric circles are coplanar circles with the same center, and two coplanar circles that intersect at exactly one point, they're called tangent circles. Notice that they could be described one of two ways, internally or externally.
Is that where they call them tangent circles because they touch at the tangent?
They touch at exactly one point. You got it, boss. Here we go. Next.
Oh, you better.
All right, moving on. Find the length of each radius. Identify the point of tangency. Write the equation of the point. Oops. Oh, man.
Good going. Good.
We're back. We're back. No harm, no foul.
Party foul.
No harm, no foul. You know what party foul is. All right. Find the length of each radius. Guys, let's talk about how we find the lengths of radius. You ready?
No.
Here's what I like to do. I like to put my finger right in the middle and count as I move along. 1, 2. That's how I do it. Okay, works every time. 1, 2, and then you get these that are in the middle right here. It's really tough. You go 1.5. Okay, so you know that's kind of how you find the radius. All right. If you really want to know how to find the radius, we'll use what's called the equation of a circle. You'll have to hang with me until next unit before I teach you that, though. Yo, what up?
Okay, so how come you can have 1.5 and 2 if it's the same on every side?
First off, there's no sides with any circles. Second off, if these aren't congruent circles, they're concentric circles.
Okay.
You with me?
You're also.
Yeah.
Tangent circles.
No,
What did I say?
they're like
Concentric?
hard.
Yeah,
Like,
you
so,
said
so if you don't go,
Definitely not concentric
if you
circles.
don't do a little cross thing with it, and you just go diagonal, then it's only 1.5. But if you go up and down, it's 2.
No.
Like, if you go through R, it is definitely 1.5.
No.
Yes, it is.
No. So S has a diameter of how many? 1, 2, 3. Time out. If the diameter is 3, the radius has to be half of 3, which is 1.5. R has a diameter of 1, 2, 3, 4. Diameter is 4. The radius has to be half of it, so that's why it's
Get
2.
it like that.
No. I mean, you could go like this. Guess what? I promise you, it's still going to be 1.5.
No, but on R, it's 1.5. Do you all see it?
I mean, nobody else sees what you're talking about. This is still going to be a radius of 2.
Through the letter R, it is only 1.5.
Why don't we just,
Oh, you have to look at the whole thing?
Okay.
And the two houses go out.
It's good question. Okay. Alright, so, what's the point of tangency here? Alright, what you would have to do is, guys, to calculate your points of tangency, you would have to think about where is this in relationship to, what? My x or my y value? Not my x value, my y value, okay? Everywhere where y equals 0 is their point of tangency, okay? Alright, that's kind of a minor thing. Alright, common tangent is a line that is tangent to two circles. Yeah, it's worth writing down. A common tangent is a line that is tangent to two circles. It's worth writing down. A common tangent is a line that is tangent to two circles.
So it's like, they both have a tangent, and since it's like ongoing, the line goes through two.
Just like what it says. It's a line that's tangent to two circles. So, in this case, both L and M are common tangents because they are both tangent to the two circles. Right? Wait, sometimes it'll look like this. It's the same thing.
No, it's not.
Same definition.
You just,
Common tangent is a line that is tangent to two circles. In this case, do I still have common tangents? Yes, I do.
Maybe go back, please.
yeah, can you please go back?
Guys, it's the same definition.
No, it's not. The other one's different on the bottom. I need the bottom little thing.
Now, are we good?
Yeah, you can go to the next one and then wait.
No. Okay, I gotta go all the way to here. Alright, I mentioned this earlier. This is a important principle about circles. If a line is tangent to a circle, it is perpendicular to the radius drawn to the point of tangency. If a line is perpendicular to a radius of a circle at a point on the circle, then the line is tangent to the circle. Alright, huge important part about this. Anytime you have a tangent, you need to write this whole thing down, both of these. These are really important. Anytime you have a tangent line or a point of tangency, the point of tangency is perpendicular. So what kind of angle is going to get formed? Very good. Right angle, 90-degree angle, okay? The point of tangency is perpendicular to the radius. You hear me? Point of tangency is perpendicular to the radius that touches that point of tangency. Yep, sorry. Okay, what does this look like? Well, one theorem that this sets up, okay, if two segments are tangent to a circle from the same external point, then the segments are congruent.
Wait, do we have to write this down?
Yeah.
Okay.
Okay.
All right.
If two segments are tangent to a circle from the same external point, external, is that inside or outside the circle?
What, external?
It's
Outside the circle. External. Okay? 2 points tangent to the same circle. If they meet at a point out here, they are congruent to each other. See? In this case, that means that AB and AC are congruent. Why? Because B and C are tangent to circle P, and therefore, when they meet at point A, an external or outside point of the circle, that means because of this theorem, they are congruent to each other.
You still not missing.
Two was sick.
Yeah, I done read it.
Alright,
You done read it?
alright, so check it out. I think this is the last one. Alright, hey guys, in this case, if it says HK and HG are tangent to F, find HG, how would I do that? I would set those equal to each other and solve. Set HK equal to HG and solve for A. That's simple, okay? Because if they're congruent, they have to be equal, correct?
Yeah.
Back to congruency a little bit. Any questions on that?
No.
You've got 2 things for tonight. You're gonna have